Hey, last one, I swear. I swear this is the last immune lecture. So we were just talking about antibodies, I think, and before that we were talking. Well, actually, we were talking about different types of immunity. Um, if you got the bacterial infection as being natural active, and the injection of the dead virus, the vaccination, as artificial active, you're 2 for 2. If you got the spider bite as artificial passive, and the placental transfer as natural passive, then you were 4 for 4. Um, Note that things were active when you were making memory cells and passive when you were just getting antibodies. Obviously, getting antibodies is not as good as making memory cells. All right, speaking of antibodies, the big limitation on antibodies is they cannot go inside cells. Okay? So intracellular pathogens are in a way protected from antibodies. But luckily, we have a method of dealing with intracellular pathogens, and that method is cell-mediated immunity. Killer T cells also lets us deal with cancer cells. Now, in order to understand how killer T cells work, we got to understand something called MHC1 proteins. This is a normal healthy cell right here. A normal healthy cell in its endoplasmic reticulum, it is going to make normal healthy proteins. Normal healthy protein production. And what your normal healthy cells do, they're going to take a sample of the normal healthy proteins. The purple guys are samples of normal healthy proteins, and they're going to display them on the surface with a MHC1 protein. So basically, what normal healthy body cells do, they take a sample of their proteins that they're making and display them on their surface for the MHC with the MHC1s. They're displaying them as a way of showing what's going on inside them. Basically, they're saying to killer T cells, look, I got a normal protein. Do not kill me. Leave me alone. However, what if a virus infected a cell? There's the virus right there. Virus goes in. Virus hijacks the cell, commandeers the cell's machinery in order to make new viruses. So now our infected cell is making viral proteins. So that means that viral proteins are going to be displayed on the surface via the MHC1s. These viral proteins will be recognized by the appropriate killer T cell, and the killer T cell will be able to respond by killing the infected cell. Basically, what these guys are doing are acting as a sign saying, hey, look who has infected me. Please come kill me right now. All right, good. Here is our killer T cell. All right. Once our killer T cell gets activated, he's going to make a whole slew of new cells. Activated killer T cells, memory killer T cells. The activated ones to deal with the here and now, memory ones for later. The activated ones, they will sidle up to an abnormal infected cell, recognize it via the MHC1 protein, then release chemicals in order to destroy him. There are chemicals called perforins, which punch holes in the infected cell. There are chemicals called granzymes. We have apoptosis happening in some occasions, cell suicide. And so we kill the infected cells. Now, of course, a memory helper T cell, a memory killer T cell, is going to undergo mitosis a lot faster. A memory helper T cell will be able to make more and better cytokines. A memory killer T cell, when it makes new activated killer T cells, they're going to work better, be better recognizers and better killers. All right, one more to do. Last one. This is the shortest lecture ever. Regulatory T cells. They have an old-fashioned name that I actually kind of like better. They used to be called suppressor T cells. And that definitely implies they're going to suppress something. So regulatory T cells, what they do is they release cytokines generally once the infection is done. And those cytokines are going to turn off helper and killer T cells. Those cytokines are going to turn off innate cells, B cells. If they were not around, then we would have these dangerous warrior immune cells active for too long, and they could start damaging your own tissues, and that is not so good. All right, fantastic, fantastic news. The immune system is done. Yay. So, that means respiratory system's right around the corner. See you guys later.